Most of us think of human memory like a digital hard drive or a security camera recording a continuous video feed of our lives. But that assumption is biologically impossible. Recalling an event is not hitting play on a saved file. It is an active, real-time construction process known as reconstructive memory. It starts with encoding. When you experience a moment, your brain does not save it as a single cohesive unit. Instead, it shatters the event into distinct sensory fragments. The temperature of the room, the smell of coffee, the feeling of anxiety. These individual data points are sorted and scattered across entirely different lobes of the brain. When you try to remember that moment, you trigger a phase called retrieval. Your brain has to rapidly search for all those scattered fragments and blindly glue them back together on the fly to form a cohesive thought. This rapid assembly is far from perfect. By the time the image is put back together, pieces are inevitably missing, leaving distinct, empty gaps in the reconstructed event. Because every memory must be rebuilt from scratch every time you access it, the foundational database of who you are is constantly unsecured. It is an open system, highly vulnerable to outside corruption. Your brain detests those empty gaps. When it encounters missing information in a memory, it will actively seek out filler material from your environment to complete the puzzle. In the mid-1970s, cognitive psychologist Dr. Elizabeth Loftus began investigating exactly how malleable this process really is. She designed a study where test subjects watched videos of automobile accidents. Afterward, the subjects were asked to estimate how fast the cars were moving when they collided. This chart shows the results of a subtle linguistic trick Loftus used during those questions. For some subjects, she used the neutral verb hit. For others, she swapped in the violent verb smashed. That single word acted like malware. The subjects who heard smashed consistently estimated the cars were traveling at much higher speeds. A week later, Loftus asked subjects if they recalled seeing any broken glass in the videos. There was no broken glass, yet the group exposed to the word smashed was likely to claim they saw it. Their brains needed the reconstructed memory to logically match the violent verb, so they simply invented the glass. This is known as the Misinformation Effect. It demonstrates that external language can seamlessly overwrite biological truth, tricking the brain into reading manufactured evidence as a completely authentic experience. The brain's drive to fill missing gaps can be weaponized to fabricate entire chronological sequences, reaching far past minor environmental details like broken glass. Under the right conditions, people can develop what psychologists call rich false memories. These are complete, complex, and entirely fabricated historical narratives that are successfully implanted into a human mind. To demonstrate this, researchers developed the lost in the mall technique. They enlisted family members to present test subjects with 3 true childhood stories, alongside one entirely fabricated story about getting lost in a shopping center as a child. Roughly a quarter of the subjects accepted the false narrative as true, and their brains began actively generating new sensory details to support it. They would describe the clothing of the stranger who rescued them, or the specific emotional panic of being separated, reinforcing a lie with hallucinatory evidence. Because the brain relies on the exact same assembly process for both accurate recall and highly detailed hallucinations, it cannot tell the difference between the two. When it comes to human memory, absolute certainty is never proof of reality. This presents a biological paradox. Why would millions of years of natural selection result in a highly complex organ that regularly lies to its host? The answer requires stepping away from the idea that the brain is meant to record the past. It was never engineered to operate as a historical archive. Its primary function is to operate as a prediction engine. In nature, survival depends entirely on your ability to anticipate and forecast potential future threats, not on your ability to accurately catalog yesterday. By breaking past experiences down into thousands of discrete, modular pieces, your brain can rapidly recombine them. It uses those old fragments to build endless simulations of situations you haven't even encountered yet. The brain willingly sacrifices objective historical accuracy in order to achieve the speed and adaptability required to navigate an unknown, dangerous environment. We do not remember our past to dwell on what has already happened. We remember it so we can actively simulate and survive the future.